Right, guys, let's have a look at 14 then. We've got the y equals 1 minus 3 lots of x to the power 4. So let's get the gradient function then, dy dx. Constant goes to 0. 4 comes down to b with the 3 to make minus 12, x to the 1 less than 4, which is cubed. Let that equal 0 then. So simply speaking, you've got minus 12x cubed, because that's nothing there, equals 0. Divide by minus 12 both sides. So we'll end up with x cubed is 0, won't we? And that implies x is 0. There we go. X equals 0. There's our turning point. So let's get the output then. There's the input. So at x equals 0 is the input. What does y equal? Well, it's 1 minus 3 times the x to the 4. The input value is 0. So I've written it like that. 0 to the 4 is 0. 3 times 0 is 0. 1 minus 0 is 1. There we go. So y equals 1. Let's just put it in a box so we remember. So there's our first place where dy dx is 0. So turning point then. So let's just draw a little sketch and mark that off. Now, here's our axes. Here it is. Here's x. Here's y. Here's 0. And we said the first turning point, if we go back, was at 0, 1. Yeah? Go back off. Input is 0, output is 1. There. Yeah, and it could be either a max or min. Might be something else. But generally that's what we draw, just to say, well, what have we got here? It's definitely a turning point, we know that. Right, let's go back and see if it's a max or min or anything like that. So we need the second derivative for that then. So d2y by dx squared then. Differentiate minus 12x cubed. The 3 comes down to make minus 36 x squared, which equals, now at the value x equals 0, which is our turning point, put 0 and you get minus 36 times 0 squared. 0 squared is 0, 36 times 0 is 0, minus 0 is 0. So you get 0. So it's indeterminate, isn't it? We don't know whether it's a max or min or what happens there. We know it's a turning point. So what we need to do is look a little bit more closely at our gradient function, dy dx. Let's have a look at that, shall we? What have we got? We've got, if I write it down correctly, we've got minus 12x cubed. Now if you look at that, right, this is the gradient. If you take x to be positive, positive cubed is positive, minus 12 times a positive number is negative times positive is negative. So this will equal negative when x equals positive, yeah? In other words, x is greater than or equal to 0. Right, that will always be negative. And when x is negative then, let's have a look at that one, shall we? Let's put greater than 0, shall we? Because that's what we're interested in, sorry. And less than 0, minus number cubed is minus. Minus times a minus is a plus. So it'd be positive, wouldn't it? When x is negative. So it's a positive slope. It's like going uphill, right, before 0. So you're going uphill before 0. Then you're going to, at 0, it's going to flatten out. And then it's going to be a negative slope. Yeah? We agreed on that? Okay, so it's a positive slope. Gets to 0, then it goes negative. Let's go down. So it's a positive slope up to here, and then it goes negative. Yeah, agreed? So let's draw it then. Okay, so it's a positive slope, comes up to a turning point, and then it goes negative. That's it. That's the curve. Y equals 1 minus 3 x to the 4. Yeah? Great. Good. Flattened out here. Not a really great quality sketch there. Let's have a look on our plot then. 1 minus 3x to the 4. See what that gives us, shall we? So let's try that one. 1 minus 3x to the power 4. 1 minus 3 times x to the power 4. Right. There we go. Goes up, flattens out, and goes back down. And characteristically it looks like this. Nice little graph that. It's done from -2, isn't it? to 2, which is quite a nice selection there because it shoots off very quickly. And what did we draw then? Let's go back here. We drew that. Slightly lopsided, but at the end of the day, it's the same thing. We could have found these roots as well, actually. Could have let that equal 0, couldn't we? We would have found those. Okay, but that's good. That's actually the plot then. There it is there. Good. So let's go on to the next one. Great.